Hello, this is Dr. Walker. This is video 230, temperature variation of resistance. This video we're going to talk about how resistance depends on temperature. So we have an equation that shows us exactly how resistance depends on temperature. The first thing to note is that for most metals, both the resistance and the resistivity will increase as temperature increases. So this is what this equation is showing us. This R0 is the original resistance before the temperature change. You're going to multiply that by 1 plus alpha. Alpha is a temperature coefficient of resistivity, so this is a constant that depends on the material. And then you're going to multiply by the change in temperature. So all of these things are going to be positive, and the whole factor here is going to be greater than 1. So you're going to multiply your original resistance by something greater than 1. So you will get a bigger resistance after that temperature increase. So the problems in this section are going to be plug and chug types. So we have one in the next slide. It could have been a guided example, but since it was just plug and chug, I just made it into a your turn. So this problem says when electric heater is turned on, the nichrome heating element is at 0 degrees Celsius and it has a resistance of 7.5 ohms. The element heats up to 800 degrees Celsius, find a new resistance. And it gives us the temperature coefficient of resistivity, the alpha for the nichrome. So this is a plug and chug. Our equation is the resistance equals the original resistance times 1 plus alpha times a change in temperature. So change in temperature is always final minus initial. So we can just plug our numbers in. We have the initial resistance is 7.5 ohms. We're going to multiply that by 1 plus the alpha, which is 0.4 times 10 to the negative 3 times delta T. Final temperature is 800 minus 0, so the change in temperature is 800 degrees Celsius. And notice that when you multiply the coefficient, which has units of 1 over Celsius, you multiply that by Celsius. It cancels out the units, so that we're left with only the units of the 7.5, which was the ohms. So plug and chug all of this in a calculator, and it's going to give us 7.74 ohms. So our temperature did increase, our resistance did increase with the increase in temperature.